Hi everyone, welcome to the Data Science Bytes channel. Data Science Explained Simple. The topic for today is memory profiling. And memory profiling is an important aspect of performance analysis and optimization for our data pipelines. Data scientists do pipelines all the time. So here are some key reasons why memory profiling is needed. So identifying memory bottlenecks in your code helps ensure the efficient use of system resources because, inefficient memory usage can lead to performance problems. Also, when you look at these memory leaks, you want to prevent them so you can help detect and fix the memory leaks, which occurs really when the program allocates memory but fails to release it. And over time, this will build up and potentially cause system crashes. When it comes to garbage collection issues, so programming languages like Python, languages that kind of do automatic memory management, if we understand how to tune the garbage collection process, this will get us very far. For scaling and performance, as application scales, and we use data a lot, we need memory, RAM, and whatnot. Inefficient memory usage can become more pronounced. So memory profiling helps ensure that the application can handle increased loads without running out of memory. Now, memory profiling can reveal specific parts of the code, like pinpoint a particular function or a line of code that is consuming a significant amount of memory. This kind of information can help and guide us, or making sure that optimization efforts are done properly and making it easier really to target performance bottlenecks and hotspots. So what are we going to do today? We're going to write simple code that consumes high memory. Then we will see how we can do line by line memory profiling. And after that, we can also do some sort of a plot against time to see that memory consumption. So let's get to it. So I'm starting here with a clean Python script, and I am going to import numpy as np, and we will also need to import the time module. We'll see in a second why we need it. And of course, if name is equal to main, then execute main. Let's go up there and do one thing. Let's define main, and inside main, the first thing we want to do is to initialize the list to store the memory data. So we can call it main data, just a list, an empty list. Then we want to do like a for loop, maybe like in range of let's do 5, because what we are going to do now, we are going to execute the same line of code for about 5 times. And the first step to do is to allocate 1 GB of memory every second. So we're going to go through that loop. Every second, we're going to add 1 more gigabyte of memory. So the size that we are actually targeting in megabytes is 1024 megabytes, which is 1 GB. And let's do data that we're going to append every time. We can use the random module, and we can get some random numbers, and that will be the mem size multiplied by a big number, 125,000. I'll explain in a second why this particular number. And then we'll take memory data, we will append to it data. This is what we will do. And what we can do as well, we can just print something like maybe allocated, maybe len of let's take mem data, because every time the length is increasing by 1, and every time we're doing 1 gigabyte memory. All right, I think this is enough. And we should not forget that we want to sleep for 1 second. So what happens here is that every time we add 1 memory, we append it to our memory data here, and then we print that we allocated X of gigabytes to memory. And after that, we'll sleep for 1 second, and then we'll come back again. And for this number here, the idea really here, if you do that like simple math, you will see that what we're trying to do, we're just trying to, if you multiply the number by this big number here, you will get around 28 million random numbers, and this will account for 1 gigabyte. So we're done with the code. Let's test it. Okay, so starting now, 1 gigabyte, 2 gigabytes. In fact, if you look at this here, you'll see that's actually increasing until it stops, until the program stops after 5 trials or 5 iterations. So 1 gigabyte, 2 gigabytes, 2, 3, and 5, and then it stops. So now we have a program that is consuming a lot of memory. But let's see how we can profile it. And to profile it, we can install just using like a pip install. So pip install memory profiler, memory underscore profiler. And because I installed it already, I have it, so it's not going to be installed in your case. It might take like a few seconds to install. All right, so how do we use it? If we come back here and we, from memory profiler, we import profile. We can use profile as a decorator. We can use profile as a decorator to our function, and it will profile our function line by line. So now let's run the script one more time, but with profiling. So if we do Python 3 -m memory profiler, and of course the script, which is mem underscore profile 1. If we do that, the script will run 1 gigabyte, 2 gigabytes to stop after 5 gigabytes. And wow, here you go. So let's have a look. So this is the profiling line by line. As you can see, memory usage, it starts with about 50 megabytes. This is booked for the profiler itself. And then at the very end, we kind of consumed 5 gigabytes. So every line is shown here. This is the line that is taking the memory. Everything else is just really 0 megabytes. But then what we can do now, if we want to really look at that as a function of time, we can just call the script, the profiling, in a different way. We can call mprof, and then mprof we can run. We can run our code. It will do the exact same thing, but additionally, it will run this line here. It will execute and save the data against time every single 0.1 second. It will give us the same output as before, but we can use this file here, the .dat file, which is nothing but just how much memory every incremental 0.1 second. But this is useful because now we can call mprof again, and we can plot it. Maybe you can just give it a title like mem underscore prof, right? Wow, let's have a look at that. We do that here in seconds. Every second we take 1 gigabyte, the second 2 gigabyte, 3, 4, and 5 gigabytes before the program actually ends at the very end and releases memory. Right, so what we have done today is we wrote a simple program, simple script with high memory consumption. We use memory profiler to profile it line by line, and also we managed to plot that memory consumption against time. I hope you found this video helpful. Stay tuned for the next one.